Good morning, mathematicians. This is lesson 18, and I love this lesson because we're representing the same situation with multiplication and then with division. So take a look at our tape diagram because we are seeing a repeat of 1/3 until we have two wholes, right? Now in task A, we are asked to represent the situation in a multiplication equation, right? Now in part B, we are asked to represent the diagram, that situation, in a division equation, which again goes to support that we are mathematicians. We're thinking flexibly about these situations, and in this way, it's not always the same process to get to the same answer. We can do it our way with what we see, right? And today is a great example of that because we're going to think about the same thing in two different ways. So let's get started with our multiplication equation. Let's think about what is it that we are seeing repeated, right? What is the number that we are seeing repeated? Because we are going to have a factor and we're going to multiply. We're going to multiply by another factor, right? And then we're going to get to our overall answer of two wholes, right? That's what we're going to see as we create our multiplication equation. All right, so what is the thing that's being repeated in this situation? What I see being repeated is a third, because I have 1/3, a second 1/3, a third 1/3, a fourth 1/3, a fifth 1/3, and a sixth 1/3 piece. Since I am seeing 6 1/3 pieces, that is where I know that one of my numbers that I need to have here is 1/3. And how many groups of 1/3 am I seeing? I am seeing 6 of them, right? 1, 2, 3, 4, 5, 6. So truly, boys and girls, A is asking us to build a multiplication equation, which we just did, because we have 1/3 times 6 and it's equaling 2. We are asked to represent the diagram, which we've done that part. The last thing that we need to do here is explain it or show it, as we often do with our illustrative lessons. So here, let's just give some thought process behind them. So I'm going to say that the diagram shows 6 groups of 1/3, and the total value is 2. Okay, just a quick sentence, almost like a caption to the equation I built, the multiplication equation. Now we are ready to think flexibly and switch gears. We are going to now consider how could we represent this exact same diagram that we have shown with multiplication. Where do we see a division context in it? Now, where do we see division? Now remember, in division, our first number is going to represent the whole thing that is going to be broken up and divided. Well, what is the whole thing that is going to be broken up and divided? It is literally this number right here. That is the whole thing. That is, yes, broken up and divided. Now, the whole thing that is being broken up and divided is the 2, the entire tape diagram. Now, our second number in our division sentence is going to represent, it could represent the portion size, or it could represent the number of groups, right? So I'm going to go ahead and choose for it to represent the portion size. 2 is broken up into pieces. What is the size of the piece? Well, the size of the piece is shown right here. The size of the piece is 1/3. So my divisor here is going to be 1/3. Now, how many of those portions do I end up with? I end up with 6. I have 6 1/3 pieces, and that uses up the entire 2 wholes. All right, boys and girls, I am going to come down below and I am going to write really like a caption that represents my equation. I'm going to say that the diagram shows that there are 6 groups of 1/3 in 2 wholes. All right. Now, boys and girls, I do want us to remember a couple key things. One thing is, and I'm going to put these notes in gray because what we have right now is perfect. This is great. If you wrote this, this is fantastic. However, there are a couple different ways that you could do your answer that would be equally correct. First of all, in number 1A, we know that there is a commutative property of multiplication. So I should have noted this. So I'm going to go ahead and put it now that of course you could go ahead and write this as 6 times 1/3 and just reverse your factors. If you simply reverse the factors, of course, you could go ahead and have the exact same explanation for A, right? Does order matter in multiplication? No. Just like in addition, in multiplication, order doesn't matter, right? We're going to get to the same result. Now, in B, we're thinking about division. Does order matter in division? Yes. Order matters in division. I cannot switch the dividend and the divisor without really changing the entire problem. However, there is something that we could have thought about differently in this one. I don't often see it in your answers, students, but we could have written this as, of course, the same dividend because we are starting with 2 all the time, right? We got to start with 2 in this particular diagram, but I could have, instead of breaking it into portion size, which I did over here, I could have actually said that I broke it up into a certain number of groups. I broke it into 6 groups. And then how much is in each of those 6 groups? 1/3 is in each of those 6 groups. Now, if I would have done that, I could have had the same blue answer, or I might have slightly changed it because I really have redefined the divisor, and because of that, I've redefined what the quotient is as well. So I might say something instead like the diagram shows that 2 wholes broken into 6 groups ends up with 1/3 in each group. A simple adjustment like that. Boys and girls, that finishes out our lesson 18 cool down.